Good afternoon. Thank you for attending today's session, and thank you to the organizers for bringing us all together today. My name is Aaron Best. I am a professor of biology at Hope College in Holland, Michigan. Hope College is a small private liberal arts college with about 3,200 students. All of them are undergraduates. And as the pandemic went on last year, and as the college thought about coming back for an in-person semester in August of 2020, I and my research group began to think about how we could use wastewater to monitor for SARS-CoV-2 and understand the potential burden of COVID-19 on campus and in the surrounding community. I'm going to take you through a brief overview of the contents of the poster today and talk to you a bit about our strategy and then some of the results that we have. Our strategy was essentially to utilize wastewater-based epidemiology targeting SARS-CoV-2 to help us to target testing of individuals on campus to those that had an indication of a need for tests. So to do this, we divided our campus into 9 different residential zones. Each of those zones had about 90 to 250 students in them, living in dorms or cottages or apartments. We also had an isolation and quarantine zone on campus that we monitored as well. We did this monitoring 5 times per week, Monday through Friday, and we were able to report results on the same day that we collected samples. So we chose a method that allowed us to have this rapid turnaround. We felt like the rapid turnaround was absolutely critical to being able to utilize this information to make public health decisions and to communicate that to stakeholders. The method that we decided to use was called the 4S method, and it allowed us to quickly process sewage samples by the addition of salt and ethanol, a pre-filtration, and then isolation of RNA with standard DNA RNA isolation columns. This method came out of UC Berkeley in mid-August, right at the time that we needed to make a decision about what kind of process to use. This was then coupled to downstream qPCR, where we targeted 2 genes, SARS-CoV-2 N1 and the E gene. In addition to these 2 targets, we targeted peppered mild model virus, PMMOV, which we used as an endogenous control as a proxy for fecal content in the sewage. This is a virus that infects plants and it's part of our diet, and we shed that into the sewer system. We also had a process control bovine coronavirus to be able to calculate efficiency. We produced results with those 3 targets, SARS, N1, E, and PMMOV, by normalizing the SARS targets to the PMMOV targets. So we simply divided the concentration of the PMMOV was used to divide the concentration of N1 or E. This was then reported on a daily basis via an Esri-based dashboard that looks something like this. And in this panel over here on the left, you see time on the x-axis and the ratio of E or N1 to PMMOV over time. And you can see that there's variation. This reporting was critical and allowed us to be able to give decision makers some information to be able to instigate follow-up tests of residents in any one particular zone. I'd like to take you through one example of what I would call a wastewater event, where we would see wastewater signal, we would instigate a follow-up test of residents in that zone, and then be able to identify those that had COVID-19 and close contacts and remove them from the zone. This is the dashboard for a particular event in one of the zones on campus. This was an early event for us. We were not sure if this would work at all, but it did. You can see here it was a long run of non-detects for the virus in this zone, and then on day 1 of the event we started to see low signal. This began to increase. The white arrow indicates a decision point where we decided to increase testing inside that zone. We did not fully test the zone immediately because we weren't sure if this was going to work. You saw the signal continue to increase. The orange arrow indicates from that testing that was instigated here, the identification of students and removal of students from those zones. However, the signal did not go away, and so we instigated a full test of the entire zone. We found 5 more students that had SARS-CoV-2, They were all asymptomatic. They were removed. By this point, it took us several days to test through the zone, and then you see that the signal goes away. On day 16 here, the first students that were removed from the zone actually came back from quarantine and isolation into the zone, and you can see the signal return as they continued to shed virus. That virus shedding for students returning after the 10-day quarantine period or isolation period typically lasted about a week. That was our observation over time. In addition to monitoring the campus, we were able to monitor the surrounding community. So we monitored 3 different sewer shed zones inside Holland, Michigan and Zeeland, Michigan. It represents about 100,000 people. We did that daily all of last year, and we worked with the local health departments to identify for us caseloads, daily case counts for COVID-19 in the community. And you can see in this graph here from September to December of 2020, the number of cases that were identified in any one day on the left axis, and the ratio of N1 to PMMOV on the right axis. You can see that the N1 to PMMOV ratio signal was very low. This is the red line. It was very low for much of September and then began to increase in October. A sharp increase in late October. You'll notice that the case counts were quite low for much of that time and then lag the signal that you see in the SARS-CoV-2. So we were able to determine that the lead time that is available to us, at least in this sewer shed zone, is about 7 to 10 days prior to the onset of cases. There are many reasons for why cases might lag the signal. It's not necessarily that the signal is really predating disease per se, but with many issues of testing and results and turnaround and those kinds of things, you would see a lag in this type of thing. We do believe that this is the kind of signal that one would begin to expect in a context that we're in currently, where you have sub-optimal levels of vaccination, and so over time you would be able to anticipate if you have outbreaks coming up by using wastewater signal. I will answer any questions. Thank you.